All right, guys, so we are starting chapter 7. And chapter 7 is all about ratios and proportions. So this first lesson is actually kind of, it's a very algebraic lesson, but almost like pre-algebra, okay? So there's not a lot of geometry in this. So we're going to start off with the first vocab term, which is just a ratio. And you should have heard it, you should have heard of it before. But the definition of it is it's a comparison of quantities, all right? Now, there's 3 different ways of writing a ratio, and that's with, so like, let's say I was comparing, let's just say I'm comparing that there are 3 boys and 5 girls, all right, in a class. So if I wanted to compare, all right, the number of boys to the number of girls in a class, all right, I could write that 3 different ways. So the first way to write a ratio is you can write it with the colon, all right? So you could do 3 to 5, okay? The other one you could write it as is you can actually put the actual word 2 in there, so 3 to 5. And then the last one is as a fraction, and you could write 3 over 5. So the 3 different ways of writing a ratio is with the colon, the word 2, or as a fraction, okay? So if we look at this first example, it says Jack swam 21 laps using the crawl strokes and 3 laps using the backstroke. Give the ratio as a fraction in lowest terms. Okay, so a couple ways is telling you how you're going to write the ratio. You're writing it as a fraction, and you have to write it in lowest terms, which means that you have to reduce the fraction. Okay, so for example, it says that Jack swam 21 laps, all right, using the crawl stroke and 3 laps using the backstroke, and we have to write it backstroke to total laps. So he did 3 backstrokes over total laps, all right, which would be 24, because you have to add the 21 and the 3 together. So reducing that, you would get 1 to 8. So what that means is for every 1 backstroke, he did 8 total strokes, okay? For B, it says compare the backstroke to crawl stroke. So once again, the backstroke, he did 3 laps to the total crawl strokes, which is 21, which reduces to 1 over 7, which means that he did, for every 1 backstroke, he did 7 crawl strokes, all right? Now the last one is total laps to crawl, all right? So the total laps is 24, and the crawl strokes were 21, which reduces to 8 over 7. Okay, nice and easy. Okay, now if we look at example 2, though, this one is talking about ratios, all right, in fractions, but this is just where the algebra comes in. Okay, so we have to remember our exponents properties, and we have to look at the fact that you have 2 monomials, all right, meaning if you look on the top, do you see how there aren't any addition or subtraction signs in there? If there aren't any addition or subtraction signs in there, it's called a monomial, all right? And so when you're dealing with monomials, we just look at individually the like terms, all right? So if I was looking at the 5 and the 10, what is 5 divided by 10? Well, it's 1/2, which means the 2 stays on the bottom, okay? Now, for the x squared and the x, you have x times x on top, and you have x on the bottom. So what you do is you subtract, all right, those exponents, and there's a 1 behind that x there. So 2 minus 1 is just 1, so x stays on the top, so x over 2. So you should have learned that in algebra class, okay? Now the next one's very similar. So you're going to look at it term by term. And so let's look at the 14 and the 49. Well, what reduces into the 14 and the 49, which is 7, right? So 2 over 7 is our start. Now, if you look, you have a squared on top, you have a to the third on the bottom. You're going to subtract them, all right? And because the a to the third is on the bottom, that's where the most exponents are, all right? That's where I start, and I do then 3 minus 2, which is 1, which means that a to the first stays on the bottom. So wherever the bigger exponent is, that's where it's going to stay, all right? Let's look at the b's. So you have b to the third on top, 1b on the bottom, right? The b's are going to stay on the top because you have more b's on the top. So 3 minus 1 is 2, so b squared, right, is on the top. The c's cancel out because there's 1 on the top and the bottom, okay? And so then this is your final answer. Okay, so if we look at example 2, this, or example 3 here, right, this one's a little bit harder here because you have to really know your algebra skills here, okay? So you have two binomials, all right? You have a binomial on the top and the binomial on the bottom because these individually are terms. Remember what I just said, terms are separated by addition or subtraction. And you have two terms in the top and two terms on the bottom. So here is what you're not allowed to do, all right? Because it's separated by the subtractions, you're not allowed to individually look at, all right, the exponents. You have to look at them all as a whole, all right? So this is a whole, all right, and this is a whole. So what we need to look at is how can we break them down in order to simplify them, right? So what we're going to do is we're going to look at this denominator, okay? So in algebra last year, you should have learned something called the difference of squares, okay? And we are going to have to factor the difference of squares. So what you're looking for, all right, for difference of squares is first of all that you have a binomial, all right? So two different terms, which is what we have, okay? Now, the word difference means that they have to be subtracted, all right? And we have that. They're being subtracted. And then squares mean that you're looking for perfect squares, all right? So x squared is a perfect square, y squared is a perfect square as well, okay? So what we're going to do to factor this, and once again, you guys should have learned this, all right, in algebra, but I'm going to keep the x minus y on top, okay? But difference of squares, the way that you factor it is I'm actually going to put my two sets of parentheses, and you're going to split up the perfect squares. So I'm going to put x here, and I'm going to put x here, okay? Plus, minus, and then the square root of y squared is obviously y, all right? And then the y and the y split up. So remember we have to look at these as a whole, right? So this is a whole, all right? And then these two on the bottom are wholes, which means that you can only cross them out if they're exactly the same. So if you look, you have x minus y and x minus y, and those are going to cancel out. But because we canceled out what's on top, we still have to have a placeholder there. So the final answer here is 1 over x plus y. And that's your final answer. Okay? All right. Let's do one more. Okay. So once again, all right, you can't just cross things out because of the fact that it has that plus sign right there. Okay? So we have to figure out a way of simplifying these binomials. So on the top, you can't really do anything with the 4, so we're just going to leave it there all over. Okay? Now, this, you can't do difference of squares because, first of all, it's not difference, all right? So it's not a subtraction. So whenever you're factoring, the first thing you really have to look at is, can you take out a greatest common factor? So is there something that you could divide out of the 4a and the 2 that will simplify? And the answer to that is yes, because you could technically divide out a 2 from those. But when you're dividing out your greatest common factor, all right, you have to put the 2 out in front and then simplify. So 4a divided by 2 is 2a, all right, plus 2 divided by 2 is 1. So we're going to now simplify, all right, the 4 and the 2, okay, and 2 goes into 4 2 times. So your final answer for this is 2 over 2a plus 1, and that's as far as you can go. Okay, all right, I'm going to pause here, and then we are going to come back and do 2 more examples, okay? I anticipate this being a little sketchy, all right, a little bit difficult because you guys haven't factored probably in a while, all right, and there's just a ton of different ways of factoring. So if you're having trouble, you need to make sure that you come into my office hours, all right, to get some help.